Alright, so I want to show you the relationship between volts, current, and resistance. And the way you do that is through Ohm's law. So these three equations are Ohm's law, where E equals volts, I equals current, R equals resistance. So in this equation, volts equals resistance times current. And current equals volts divided by resistance. And then resistance equals volts divided by current. So to give you an example, I have a 22 ohm resistor and a 270 ohm resistor in series. And these two resistors equal 292 ohms. And they're at 5% tolerance. And we, let's say we put 12 volts to that circuit, DC. So we know we have 12 volts to 292 ohms, and we want to figure the current draw through that circuit. So current equals volts divided by resistance. So we know we got 12 volts to the 292 ohms. So current equals volts divided by resistance. So let's get out our calculators. Alright, so 12 volts divided by 292 ohms equals 0.041 amps. So it would be 41 milliamps. Alright, so let's try it out on a real circuit. So here I got the same thing on my breadboard. I got a 22 ohm resistor and a 270 ohm resistor, 5% tolerance. And I'll put 12 volts to it from my power supply. Let's measure the actual resistance across these two resistors. Got my trusty multimeter here. We'll switch it to ohms, and we'll let it level out there at 286.5. Alright, so we got 286.5 ohms, and the voltage is switch my multimeter to volts, and we got 12.01. Alright, volts. So let's do the math on the calculator again. So 12.01 volts divided by 286.5 ohms equals 41.9 milliamps. So that's what we should measure, 41.9 milliamps. So let's put it in series with the circuit here so we can measure the amps. Alright, so I'll switch it to milliamps, move my probe over. Alright, so so my meter reads, yeah, 41.9 milliamps. Woohoo! That's exactly what the math shows. It shows a negative there, but that can easily be fixed. It's just the direction of the current flow making it show that, so just switch that around. There we go. So let it stabilize again, and it'll probably go back to 41.9. There it is. So there we go. The math shows the reality of the circuit. Alright, so let's just try another equation here. So let's do the voltage drop across this 270 ohm resistor. So that resistor, make it to ohms, move our probe back to ohms, and you need to disconnect the supply voltage from the circuit. Alright, so that resistor is actually reading. Let it stabilize here. Alright, so that resistor is stabilized at 265.2.
Whoa.
I know you did. Ohms. Let's just measure the other one while we're here.
Whoa. Whoa. Whoa.
And that resistor measures 21.9 ohms. Alright, so we know we had a current draw of 41.9 milliamps. So we want to figure the voltage drop across this resistor. So switcher to voltage, and the voltage equation is E equals resistance times current. So we know the resistance is 265.2 ohms times 41.9 milliamps. Let's get out our calculators. You gotta change milliamps to actual amps, so it'd be 0.0419 times 265.2 equals 11.11 volts. Alright, let's see if that's really what it is. And that's pretty close. It's 11.10. Alright, so that equation works. We can try to measure resistance also by this equation. So let's say we don't know the resistance. So we know the current draw is 41.9 milliamps through the circuit. And the voltage drop across that resistor is 11.1. So we got 11.1 volts across that resistor. So to calculate the resistance, we would take this equation, which is volts divided by current. So we know it's 11.1 volts divided by 0.0419 amps equals 264.9 ohms. Alright, so let's check and see if the equation's correct. So the meter reads 264.9 and the calculation reads 264.9 ohms. Well, the meter went up to 265, but either way, that's pretty close. So that's Ohm's law.